Welcome to Algae Romulus Prep Academy. The lesson for today is Intermediate Value Theorem. The Intermediate Value Theorem states, if f of x is continuous on the interval a to b, and f of a is not equal to f of b, and f of c is in between f of a and f of b, then there must exist at least one x value c on the interval a to b, where f of c is between f of a and f of b. So, does f of x equal to x cubed minus 4x squared plus 1/3 have a value of f of x is equal to negative 4 on the interval to negative 1 to 0? Well, let's find out using intermediate value theorem. We know f of x is continuous on the interval the a to b, since f of x is a polynomial. To find f of a, we substitute negative 1 in for x, and we get negative 14/3, which translates to negative 4 2/3. Now that we know f of a, let's find f of b. To find f of b, we substitute 0 in for x, and we get 1/3. Now let's check for f of c. In this case, f of c is in between f of a and f of b, therefore intermediate value theorem applies. Therefore, there's at least one c value between the interval negative 1 and 0, such that f of c is in between negative 4 2/3 and 1/3.
Here we have f of x is equal to 5 over 5 minus x squared. Does it have a value of f of x is equal to 2 on the interval 0 to 3? First, we have to check if the function is continuous, so we set the denominator equal to 0 and solve for x. X is equal to negative root 5 is not in the bounds of 0 to 3, however x root 5 is in the bounds, creating a vertical asymptote. This vertical asymptote is created because when we plug in root 5 into f of x, we get 5 over 0, which is a number over 0. Therefore, it isn't a removable discontinuity, and it's a vertical asymptote. Due to the presence of this vertical asymptote at x is equal to root 5, the function is not continuous within the interval 0 to 3. Therefore, the intermediate value theorem does not apply. No conclusion.
For our third example, f of x equals 2x plus 4 divided by x plus 3. Is there a value c on the interval negative 2 to 4 where f of c equals 1.75? We must check for continuity on the interval and see if f of c is between f of a and f of b to see if the intermediate value theorem applies to this problem. To check f of x for continuity, we must see where f of x is undefined. To do this, we set the denominator equal to 0 to find that it is equal to 0 when x equals negative 3. If we plug negative 3 back into f of x, we can see that it makes a number over 0, which means that there is a vertical asymptote at x equals negative 3. However, since negative 3 is not in the bounds of negative 2 to 4, it does not affect continuity on the interval. Since there are no removable discontinuities, we know that f of x is continuous on negative 2 to 4. Now, we have to check f of a and f of b. To find f of a, we simply insert a, or negative 2, for x in f of x and solve. Doing this, we find that f of negative 2 equals 0, which means that f of a equals 0. Similarly, to find f of b, we insert b, or 4, for x in f of x and solve. Doing this, we find that f of b is approximately 1.7143. So far, we know that f of x is continuous on negative 2 to 4, f of a equals 0, f of b is about 1.7143, and f of c, which was given in the problem, is equal to 1.75. However, f of c, which is 1.75, is not between f of a, which is 0, and f of b, which is approximately 1.7143. Therefore, the conditions for the intermediate value theorem are not met and it does not apply to this problem. This means that there is no guaranteed value c on the interval a to b where f of c equals 1.75.
Thanks for watching Algeomula's Prep Academy. Make sure to like and subscribe.